Going live, sorry.
Can we start now?
Yes, please, we can start right now.
Okay. Start now.
Yes, please.
Hello, where?
Yes, please, we can start right now.
Okay. Now? Okay. Start now.
Yes, please.
Hello, where?
Yes, please,
Hello,
we
where?
can start right now. Please, we can start right now.
Okay. Now? Okay. Start now. Okay. Can you mute your microphone? Hello, where?
Yes, please.
Hello, everyone. Welcome to join the TRA webinar. First of all, thanks to TRA to give this opportunity to me to show this presentation to you. Before we start, please allow me to introduce myself briefly. My English name is Sean, and I have already been working in this industry for more than 12 years. And currently, I'm working on 5G. Okay, so I'm studying the 5G applications. Okay, so today our topic is focused on 5G 2B autonomic applications. One of them, the autonomous driving. Okay. We know that there is one saying we call 4G can change the life and 5G will change the society. Okay, so we know that how 5G can change the society just based on the 5G autonomic abilities. Okay, so maybe we have some discussions before about some other abilities such as the cloud VR and connected drones and so on. So today our topic will focus on another topic focus on autonomous driving. Okay, so let's have a introduction about today's topic. So today's topic we will have three parts. The first one we will introduce the development of the autonomous driving technology. Okay, so in this part we will introduce how the technologies evolves. Okay, we know that the autonomous driving is not first emerged in 5G. It has a very long history. Okay, and a lot of companies, a lot of factories, companies, they are working on this for several years. And today we will first introduce the development of this industry. And the second part, we introduce the 5G relationships between 5G and autonomous driving. So how can 5G helps the autonomous driving, and what technologies can 5G provide to this industry? Okay. The last part, we introduce some successful use case about the driverless car, the autonomous driving, okay, based on 5G. Okay. So let's begin with the first part, the development of the autonomous driving technology. So before we talk about the autonomous driving, here we can see some introductions about this industry, the autonomous driving. So we can see here in this page, there are three institutes, three organizations, which is NHTSA, SAE, and the China Manufacturing 2025. Okay. So these three industries, institutes, they are different organizations. For example, the NHTSA, this is the organization, the government organization from United States of America. Okay. So these institutes, they are working on some the highway securities. So in this industry, in this institute, they classified the autonomous driving in levels, start from level 0 to level 4. And the second one is called SAE. So the first one is the United States, their government organizations. The second one is the international organizations, all the car manufacturers, aliens, they are joined in this institute organizations. Okay. So we can see that this organization, they also defined the autonomous driving into several levels, from level 0 to level 5. In total, there are 6 levels. And the last one is China's organization. Maybe this is the the Chinese organizations. Another way is the Chinese wheels on the driverless car or the autonomous driving. So we can see different organizations, they all divided the this autonomous driving into different level. So we can see that the autonomous driving, this industry is not very simple. It can be divided into several levels. So we can take these different organizations, their classification into consideration to take their classification as a reference. The final target is like the L5 or L4 in the United States standard. Okay, all of them, they are full autonomous driving. So that means we can just get in the car and input the destinations. The car will send us to the destinations securely. And L0, level 0, that means there's no self-driving functions. The drivers, they must drive the car by themselves. Okay, so between the L0 to L5, we can also divide them into several levels, especially for the current driverless cars. Maybe most of the current driverless cars, we are located at level 2 or level 3. It is partial autonomous driving or limited autonomous driving. For example, maybe some of you know about something about the driverless car. For example, like the Tesla. Now, maybe you see some videos before. Some people, they drive the car with the assistance. That means the drivers is not control the car in some special scenarios. For example, like the highway or some other scenarios. So the final destination about this autonomous driving is finally we need to support level 5. So the people, they are not, it's unnecessary to do the operation. The car will do the operations by itself. Okay. But maybe we need some time to support level 5. So different technologies we will work together to support that. And what's the relationships between 5G to this autonomous driving? So what's the relationships? The 5G can help us to support the internet of vehicles, which is called IOV. Okay, so before we introduce the relationships between 5G and the autonomous driving, we have to introduce this concept called IOV, the International of Vehicles. Okay, and the International of Vehicles, we can take this photo as a reference. They can be divided into several parts. For example, the vehicle to vehicle, the vehicle to network, the vehicle to pedestrians, the vehicle to infrastructures. So in total, there are 4 kinds of IOV. So the traditional connections, usually the user equipment or the car will connect it to the networks. For example, connected to the operator's base station, the operator's networks. So this is the most simple one, the vehicle to network. Okay. And in 5G, we will have some other abilities. We can support the vehicles connection to vehicles. We call them V2V. So this is the new kind of technologies. It allows the car can connect to another car directly without the connection to the networks. We know that when we make the phone call to another one, for example, one people, they make a phone call to another people, even if these 2 people, they are in the same room, the signals, they must pass by the networks and then go back to another people. But for this technology, V2V, we allowed the car communications to another car directly. So this is the new technology which can reduce the latency. So the connection, the directly connections, the most important functions for this is to reduce the latency. Okay, And the other two kind of connections, we call them V2I, the vehicle to infrastructures. So the infrastructures can be divided into several parts. For example, you can imagine such as the traffic lights and the roads. So there will be some guides along the roads. Okay, so every intelligent devices, we can call them the infrastructures, the intelligent infrastructures. Okay, and by this technology, the car and the roads, the infrastructures, they can work together. They can guide the car to do the driving. Okay, and the last one is called V2P, the vehicle to pedestrians. Okay. And I'm afraid this is the most important one, right? So the driverless car, the most important things for driverless car to guarantee the security. So we must keep everyone safe, even for the pedestrians. When the people walking, we must avoid to have some accidents to these people. So we must allow some vehicle connection to the pedestrians. Okay. So just based on thanks to 5G, we can provide 5G can provide us such kind of connections. These four kind of connections. Okay, and in the left part of this slide, we can see that the IOV can also divide it into several levels. Okay, the final target is the full IOV. Maybe for the time being, currently speaking, our IOV can support the vehicle to network. And the latest version from the 3GPP, they have already defined a vehicle to vehicle connections. And the vehicle to pedestrian connections, we can imagine, usually we can consider this kind of connection to the vehicle to smartphone connections. We consider that the pedestrians, they will have a smartphone. But in the future, even the people, they didn't bring the smartphone, we can also support the connections to them. Okay, so this is maybe currently we cannot support very good about this vehicle to pedestrians. And the vehicle to infrastructures, now the current solutions, we have partial supports. For example, we can support the vehicle to part of the infrastructures, but not all, because we need the infrastructures to support the connection to the car. So some of the infrastructures, we need to change them, upgrade them to the intelligent one. Okay, so maybe not all the infrastructures, they are the intelligent infrastructures. In some cities of China, they have already do some tests. For example, the traffic lights. The cars can connect to the traffic lights, and the traffic lights can do the analysis about the traffic loads in different directions. And then they can adjust the durations for the traffic lights, the green lights, the red lights, the duration based on the traffic loads. Okay. In the future, we can support more about this. So V2I is partially supported now. Okay. So this is the concept of IOV. Just based on the IOV, we can support the driverless car, the autonomous driving in the future. Okay. So the KIOV goals, the final one, the target one is called unmanned driving. So the driver will be released. So in the future, for example, like this picture shows, in the future, every morning, imagine like this way. Every morning when you go to the office, you only need to get in the car and input the destinations, and then you can do your own things without driving. The car will send you to your office directly. Yeah, but now, currently, we cannot support such kind of applications because we need to do a lot of deployment of 5G networks and also some upgrades of our infrastructures, include the roads, everything. Okay. And how about now? What can we do now? Now we can support level 1 or level 2, drivings. Some cars, they have already support part of the unmanned driving. Just now I take some example based on Tesla, and also some other internet companies. They are working on this. For example, like Google, and in China we have some companies like such as Baotou. They are working on these technologies. Okay, so we can find that not only the car manufacturers they are working on the unmanned driving. A lot of high-tech companies such as the Google and the Baotou, they are working on this. So this is the very big industry, and 5G we can provide help them to have better performance. Okay. So this is the unmanned driving. And another thing I want to emphasize is that for the unmanned driving, it's not only the car itself, it also includes the roads. So the unmanned driving, they are not only the things related to the car, but also to the roads. So only the car and the roads work together, we can support the unmanned driving. And in my opinion, maybe the car itself, the technologies based on the car itself is simpler than the roads, because if we want to support the unmanned driving based on the roads must be a lot of upgrades. We need to do a lot of more works to support the roads, the intelligent roads. Okay. And such kind of works, maybe they have much more than the car upgrades. Okay. So this is the infrastructures, the roads will work together with the car to support the unmanned driving. Okay. And just like eyesight, the driverless car, it is not the new technology. Several before 5G, we have already heard about something. Some companies, they have already support the driverless car. For example, like Tesla. But Tesla, they have a very terrible accident before, and some drivers even died because of this. So let's do some analysis on the pain points in the current unmanned driving. Okay. So the current solutions for the unmanned driving, usually they are using the local analysis of the car. So the car, they will use some technologies like the radar, the cameras. They will do the analysis based on these two inputs. And then they will they will analyze the environments around the car. But there is some problems with the radar and the camera because sometimes the camera and the radar, they will do some wrong recognitions. For example, in this accident scenario, the Tesla cars, they identify there is the truck and this color is white. And the cameras do the analysis about this truck. They identify this white color with the sky. So they didn't identify this truck. And then they have some accidents between the car to the truck. Okay. In another scenario, they also have some problems. For example, in this corner, in the road cross, maybe here in this corner, in this road, this corner, there is some very high building. There will be some block between the car and the truck. By radar or by camera, we cannot find the car, which is blocked by the very tall building. So in such kind of scenario, the accident occurs. So how to solve this problem? Okay. We can turn to help from 5G. So 5G breakthrough points in this industry. So how can the 5G to help us? For example, in this scenario, in the cross scenario, if there is some blocking between two cars, if they use the 5G technologies, the car can connect to the 5G base station, and another car can also connect to the 5G base station. And the two different cars, even they are blocked by some very tall buildings, they can still share the information to each other. So when the car comes to this cross, they can send some alerts to the another car in advance before the crashing. Okay, so only 5G can have these abilities to share this information to each other because the 5G coverage is much better than the car radar signals. Okay, so here is the NLOS scenario. We call them non-line of sights. The different cars, they cannot see each other. And also 5G can also works all the time, 24 hours every day. Okay, and the security level will be very, very high. The operator's network is very, very high levels. They have a very, very high levels of the securities. Okay, so reliabilities and also the reliabilities. That means every time when the networks have some problems, we will find them immediately. And also our product, we have some abilities to recover very, very fast. Okay. And another very important technology which 5G can help us in the driverless car scenario is the high definitions of the locationings. Okay. So 5G can provide us the high definitions, the high accuracies about the locationings. We know that the driverless car has very high requirements on the locationings, the positionings. If the positionings is data have some wrong data, they will have very terrible results. And the 5G we can support a very, very high accuracies. And another very important abilities for 5G is that 5G we can support very, very low latency. So when different cars, when they share the information to each other, we can reduce the latency based on 5G. And in this case, when the car moving in the very high speed, so the time, the latency is very, very serious. Okay, so even for maybe 100 milliseconds, there will be totally different results. Okay, so 5G we can support minimum to 1 millisecond latency. So this is very important for driverless car. And another two different technologies. Just now we talk about 5G. They can support a lot of new features. The performance of 5G is very important. So how the 5G can support this very good performance? Usually we can divide them into two very important technology. One is called the edge computing. Which means we move the server to the edge, very close to the users. In this case, the server is very close to the car, and the distance, the latency between the car to the server, called MEC, edge computing, mobile edge computing. Okay. And another very important technology is called network slicing. Maybe you heard about something on this, right? The 5G network slicing. So the 5G network slicing is a very important technology which can help the operator to reduce the cost to deploy the 5G. So for the driverless car, usually we need to deploy the very good coverage everywhere at least along the roads, right? So, but this is only the wireless part, the base station part. But we know that the whole 5G networks includes a lot of other parts, not only the wireless, but also the transportations and the core networks. Maybe for some scenarios like the driverless car, we care about more on the wireless part, but how to reduce the cost of the transportations and the core networks. We can deploy the network slicing. Different slice, they can share the core or the transportations. So that means network slicing allow us to provide different service to different logical networks by using the same hardwares, the physical networks. So this is the key informations, the key points for the network slicing. And network slicing is also one of the most important technologies in 5G. Just by these technologies, we can provide different service of qualities to different applications. Maybe this slice, we define this to driverless car. Another slice, we define them to the cloud VR. And the third network slice, we define them to the connected drones. And all of these network slicing, different slice, we can share the same base station, the same transportations, and the same core networks to reduce latency. And another very important thing for network slicing is that we can divide the control plane and the user plane into different parts. For the driverless car itself, we only need to deploy the user plane, the driverless car servers to the edge. But the control plane, we can also deploy them centralized. Okay, so just thanks to the network slicing, we can support the edge computing and also the different technologies. They share different slices, share the same hardwares to reduce the cost. Okay, so here two very important technologies which can help the unmanned driving. One is called edge computing, and the other is called network slicing. Okay. And the second part, let's talk about some applications based on 5G in the autonomous driving scenarios. Okay. First of all, let's do some analysis about the applications, the possible application scenarios about 5G autonomous driving. So totally, we can divide them into three big parts. One scenario is the urban road scenario. In the very dense urban, in our city size, in the center of the city, such kind of scenarios. Okay. And maybe this is most close to us, to the ordinary peoples. This is the most common scenarios. The second one is the confined area scenario. Maybe this kind of scenario is not very common to every ordinary people. For example, in some factories, in some like the airports or the seaports. So different application scenarios. Yeah. And the last application scenarios, we can consider this as the low speed scenario. So people, they don't have the high requirements on the moving speed, but we need the security level must be very high. So this is a low speed scenario. For example, like the airports or some campus. Inside the campus, different buildings, we move to each other. We have this application scenario. Okay, and in details, we can classify them into the red part. These six scenarios. The first scenario is called unmanned buses in the urban road scenarios, right? So people, they can drop into the unmanned bus, and this is the public bus, maybe like that. And for the private drivings, maybe the first application, we can try to deploy this to the taxi. So the unmanned taxi. Maybe now no cities, they not yet. We have not tried this. Maybe in the future we can support this. Okay. And for the confined areas, for example, we can consider the high-speed transportations, the highway transportations, right? This is the confined area. So, and also some other scenarios like the ports or the mining systems, which is very dangerous operations. We can do the remote control, such kind of operations. So such kind of scenarios, not all the cars are allowed in this scenario. And maybe the car is not a very simple car. They are just some very special customized cars. And last one, low speed scenario. This is also not very common. For example, like the AGV in some factories, right? Some factories, we need to move some product. We can use such kind of AGV, the vehicles, to carry some product. And last one is the low speed, like the campus or airports. So maybe this one, the last one, it seems like the shuttle bus, very similar to that. and we can also support the unmanned shuttle bus. Okay. So let's introduce this one by one. Okay. The first application scenario, let's focus on the AGV. AGV is short for automated guide vehicle. Usually, such kind of AGV is usually is used in some factory scenarios, intelligent factories, maybe like some manufacturing factories or the logistics factories. And before this AGV appears, usually when we need to take some products, we have to send some laborers, some mine hands to some mine to move this product. By this AGV, we can reduce a lot of cost on the laborers. Okay, and the AGV, the traditional AGV, usually they can only move in some dedicated lines. They cannot move to the other lines. But based on 5G, thanks to 5G, we can allow the wireless AGV. So the roads, the paths of the moving of the AGV can be very flexible. Everywhere they can move. Okay, so this is called AGV. Usually it is used in the factories. Okay. And how to support this AGV? So usually we use the 5G. We deploy the 5G MEC in maybe in one dedicated factories. In this case, we only provide this AGV service to them. This is called dedicated networks. And for the upper layers, they can share with some other slice. Maybe the other factories, they can use the same core networks. Okay. So this is some solutions. And currently, Huawei will have some solutions, and we also do some tests together with some factories. Okay. The second scenario we introduce is the low speed scenario, which is in our slides, we just take one of them, is the airports. So in some very big airports, maybe in the UAE, we have a very big airport in Dubai, right? I went there many times. And people, they will have one demand. When people transfer from one port to another port, they will have a very long road to go. So we can deploy the autonomous driving in this scenario, like the shuttles with these low speed scenarios. And in this slide, they just do some analysis maybe based on China's airports. But I'm afraid I think in UAE, in Dubai, the airports, they have more passengers. So you can try to deploy this. And in China, we just do some tests in some airports. They deploy some the unmanned driving cars. The people, they can rent this, just input the destinations, and then get in the car, they can send you to the destinations. Okay. But this moving speed is not very fast. And also this scenario is indoor scenario. So usually we use the 5G indoor solutions to have this, to support this, like the 5G lamp sites. They can support the high definitions of locationings and also the very low latencies. Okay. So this is the one of the use case for the airport scenarios. The people, they transfer from one port to another port, they will use this. They can try to use this. And the third application scenario is for the high-speed freight transportation. And maybe different countries or different cities, they are different. A lot of cities, maybe between different cities, when we transfer some product, we will use the very big truck. And usually there will be a group of trucks. They will move together. So we can do the management based on 5G. 5G can help us to reduce this the pain points of the current scenario, current industry. So we can say that the current pain point for this industry is showed here. Usually, generally speaking, the efficiency is very low and the cost is very high. Yeah. So based on 5G, 5G can do the arrangements for these trucks, and also helps them to drive automatically to reduce the cost of the labors of the drivers. But this one, this kind of application scenarios, we need, just like we said in the first chapter, is that we need not only the truck support 5G, but also the infrastructures together with the truck, like the highway. We need to do some upgrades, maybe install some base stations along the highway, and also some other intelligence equipment to do the monitorings about this truck. And in these scenarios, in the networks, how can we support this? So just like I said, not only the car, the truck, we need to do the upgrades, but also the roads. For example, we will install some sensors and cameras. And these sensors and cameras, they will be installed along the roads, along the highway, and they will all connected to the servers by the 5G networks. And the servers, they will do the analysis about the truck and send the commands to the truck, okay, to control them. So this is the structure for the 5G and the highway transportations. Okay. And the next one is called unmanned mine vehicles. Maybe this is also not very popular, not very common to every country or city, because some city maybe they don't have this scenario. This scenario is called the mining scenario. We know that the mining scenario, usually the most important things is the safety, how to keep the workers safe, okay, and especially in some very dangerous scenario. So we can use the unmanned vehicles to do the very dangerous operations. Okay, and this scenario, we need the very low latency. When we do some operations, we need to remotely, we need to reduce the latency to support the operations in the local parts. Okay, so this one, even if the accident occurs, only the equipment they are destroyed, but the people, they don't get hurt. Okay, so this is very important applications. In China, a lot of mine factories, they have already adopted these solutions. But maybe only in some limited scenarios, only for the dangerous operation scenario. Okay, and in these scenarios, we have very successful applications in China. In this case, we support the wireless 5G coverage in all the mining factories. And people, the drivers, they only need to control the trucks or some machines remotely without driving them locally. And this, how to control this? The trucks, the equipment, the local equipment, they can support the cameras, the high definition cameras. And then the drivers, they can watch these videos remotely and then identify the environments, do the drivings remotely. Okay, and also by this technology, we can also support the efficiency. The truck moving speeds can be upgraded to 30 kilometers per hour. It's much higher than the people driving, okay, the drivers driving. Okay. And the next part is the unmanned buses, unmanned bus. So this one, usually it will be first used in the public transportation, especially in the urban sites. People, they will use the bus every day, so they can provide this unmanned bus to provide the service to the passengers. Okay, and about this, not only the unmanned bus itself, we can also provide the entertainment in the bus. We can provide the Wi-Fi connections and also the IPTV connections, and also the high-level positionings. So when we take the public bus, usually the most important things is to find the locations of the bus. So how long time do we need to wait? Okay, so by this technology, we can provide more services to the passengers. Okay. And next one is the autonomous driving based on the taxi. I'm afraid now maybe we don't have these applications, the commercial one. We only do some tests because the taxi we have very high requirements. Not only because compared to the just now we mentioned the bus, usually the bus, their roads, their path is also usually is fixed. So the bus they will go by the dedicated path, but the taxi they will go everywhere. So this application scenarios we need even more requirements for the 5G coverage, 5G deployments. Okay, so maybe the public bus will be first commercial, and then the taxi. When the 5G becomes more mature, we can use the driverless taxi. And maybe in the future, now we have Uber, right? And what we call the Uber, the drivers they will come to us and take us. And in the future, we can imagine that when the 5G coverage is very good, and when we call the Uber, maybe there's only the car comes to us, and then we can get in the car. In your smartphone, you have already input the destination. The Uber driverless taxi, they can send you to the destination. So we don't worry about the security, whether the driver is the bad guys or something. So this much better than the Uber current solutions for the Uber. Okay, so but in my opinion, these solutions we need to wait several years, maybe 2 or 3 years later, we can try to have this. It is based on our 5G deployments. Okay. Must be very good coverage, high deployments of 5G. We can support this. So for the solutions of the V2X, so we just enable this V2X servers and the edge computing, these two technologies together. In the wireless parts, we will based on 5G. So the 5G coverage, we provide the last miles of coverage. Okay. So this is the 6 application scenarios we just showed to you. But we know that maybe this only from Huawei part, we provide you 6 reference, the 6 scenarios as your reference. But in the future, maybe we can even develop more applications. Not only these 6 scenarios, we can also use the autonomous driving. So you need to think about yourself, what kind of scenarios can you use in your city, in your industries, in your city, which kind of scenarios you can try to use 5G to enable the autonomous driving. Okay. So the last part, we will show you some successful autonomous driving use case, which has already been commercial in some cities. So let's have a brief introduction about this. So the first application is in China, Yanchong Expressway. So this is the highway in China, between different 2 cities. And in this road, we have already support the autonomous driving. So in this road, we installed a lot of such kind of equipment, the cameras and the sensors. Every light pole, this light pole, we install this. Maybe not every of them, part of them, several of these street light poles. We install these sensors to help the car to do the driving. Okay. And this is located in Beijing. This highway is in Beijing. But not very long. It's just a part of this highway, expressway. We use this. And the solution is like this way. We only focus on the, currently we focus on these two solutions, the V2I and the V2V, especially for the V2I, the vehicles to infrastructure. So along this road, the highway, we install a lot of these sensors and the servers to help the car to do the autonomous driving. Okay. And there is some video about this Yanchong Expressway. Maybe later we can share you the link about these videos. You can share. Now we have already support this driving without the drivers, but we still have sent some drivers inside the car just in case. The second very successful use case in China is the mining vehicles in the inner Mongolia of China. This city is called Baotou, this city. So in this mining factories, they deployed these remote control mining cars, mining trucks, and the workers, they are unnecessary to drive in the car locally. They can control the bus, control the trucks remotely. So by this applications, we can reduce a lot of accidents, save a lot of lives. So many news they occurs about this. The mining systems, the mining industries, usually they will have very terrible accidents and the people died. But by these solutions, we can reduce this accident occurs. Even the accident occurs, the driver is not in the truck. Okay. And for the mine vehicles, the solutions is like this. If we want to control the truck remotely, we must get some inputs from the truck. So in like this way, the mine we will install a lot of cameras. So in the car, both in the car and along these areas, so there will be a lot of cameras. So these cameras, they will upload their videos to the 5G networks, and the 5G networks can transfer these videos to the remote control centers, and this latency is very, very short. They can be lowered to milliseconds level. And then the controllers, the people, they can control these trucks remotely. Yeah. And by these applications for the unmanned mining trucks, we can reduce the labor cost and also reduce the energy consumptions. And also in total, the efficiency is much more improved. Here are some status. You can take this as reference. And also there is another application videos. Later we can share you the video links and you can watch this video. Okay, so that's all of today's contents. And any questions, you can also type this your questions in the chatting windows, and we can do some discussion on that. Okay, so any questions, you can just input this into the chatting windows. We can discuss on that. Let me see. Okay, there is one question. How the pedestrians will be connected to the vehicle through phones? Okay, this is a very good question. So just now we mentioned the V2X. We include one of the scenarios, the vehicle to the pedestrians. Currently, the current solution between for the V2P is really the connections to the smartphone. Okay, so we consider that people, they have the smartphone. We can send some signals to the networks, and the networks share this information to the car. But in the future, we can imagine that even the people that we don't have the car, we don't have the phone. For example, some kids, maybe they don't have the smartphone. We also need to support the connection between the people to the car. Okay, so how to support this? You can imagine that we can allow a lot of technologies we're working together. For example, we can also use the radar and the cameras. So different car, they can share this information. For example, maybe one car, they have already identified there is one pedestrian along the car, and this car, they can share this information to the other cars. But the car, they only identify the pedestrian. If the pedestrian, they didn't bring the phone, they can identify the people by the radar or the camera. But not only the car can identify the people, but also the infrastructures, the roads, maybe. For example, maybe this scenario is very similar in the cross scenario, right? When the people passing the cross, we can support the infrastructures. They can identify the people, and then the infrastructures, they can share this information to the car. Okay, so in the future, we can support the pedestrians, even if they didn't bring the smartphone, we can also support the connections to the pedestrian. Okay, next question. Whose safety should be prioritized in autonomous car accidents, drivers, pedestrians, or based on situation? Okay, this is a very interesting question, right? I think this this is also what we need to study about this. For example, when the accident occurs, maybe we don't hope this occurs, but maybe some special scenario, they still have some accident occurs. So when the accident occurs, who will take responsible for this? I think this is not a simple technology question. It is the society problem, right? So this is based on very complicated scenarios. Maybe the whole society we will have some discussions on that. Whether this is because of the pedestrians problem, or because of the car problem, or even the operator's space station problem. So I think maybe the authorities or the governments, before they deploy this driverless car, they must make the laws in advance. Just consider that when the accident occurs, how to identify the responsibilities for this accident. This is very, very important things before we deploy the driverless car. And this is really a good question. So sometimes usually for the engineers like us, we only focus on the technology itself. But this technology, this system, this unmanned driverless car, this kind of system, they are not a very simple technology problem. There will be some other things we need to consider about. Maybe the maybe the philosophies or the societies, right? If we can guarantee the security level is 100% security, when the accident occurs, maybe it's just because of the pedestrians, the people. Maybe some people, they don't obey the rules, right? When the red cars, they cross the roads. Even now we have this sort kind of problem. I don't think some kind of problem it is because of 5G and the driverless car itself. It is the society problem, not the technology problem. Okay, very, very good question. This one, this problem we must consider about before we deploy the driverless car. Okay, okay, very good idea. And any other question? Okay, another one. Since it is the network of servers, there is possibilities of car getting hacked. In which way the car can be hacked, and how to prevent it from being hacked? Okay, this is another very important topic and a very, very good question. Okay, so people, they only have this worried about this when we got in the car, and this car is not controlled by ourselves. People, it's very normal to be worried about this, right? your fate is controlled by the other people or by the technologies, by the other technologies, right? This is a very maybe people they don't get used to this, and how to guarantee the security is really important. And before we can imagine like this way. We can compare the 5G solutions to some other solutions for driverless car. At least 5G, we have very, very high security level. That means the operator's network is very, very hard to be hacked. Maybe you heard about a lot of news. Some big companies, their internal networks being hacked by some bad people. But it's very, very hard for the hackers to hack the operator's network, because one of the important reasons is that the operator's network is the private network. It's the dedicated networks. It's not the public network. Okay? So this is also the advantage why the 5G is very important to driverless car, but not the other internet technologies. So this is one of the advantage for 5G in this industry. Okay? And how the 5G can guarantee the high securities. They also have a lot of technologies to support the high securities. For example, like the encryption algorithms. 5G, we have much complicated encryptions technologies. And also, not only the wireless part, but also the core parts, core network parts. As far as I know now, for the time being, 5G security level is very, very high, almost the highest one for the security level. Okay, and so for details, maybe we don't have too much time to study in, but 5G really they have a lot of guarantees for the security level, and we also just now we also mentioned that. 5G can change the society. So one important way to change the society is to enable the IoT. So IOV, Internet of Vehicles, is just a small part of IoT. Everything in the future can be connected, right? So before we design these technologies, we have already considered that in the future, all the devices will be connected. So security will be very, very important. So imagine that every smart devices can be hacked by people. This is unbelievable. So we don't allow this happen. So when this technology, when they define these technologies, we have already considered about this, how to solve these security problems. Okay. Also very good question. Let me find whether there are some other questions. Another one, what kind of data is collected for autonomous cars? Okay, this is also a very good question. Okay, so the data here is on a very complicated one. Usually, we can consider that the data collected by the autonomous cars, usually the car, before I answer this question, you must know one thing first, is that 5G cannot decide the driverless car itself. That means, what I mean is that driverless car, the main roles for the driverless car, it is the car itself. So 5G only helps the cars sharing the informations to each other or to the networks. Okay. So the driverless car itself, it is the main job roles. The main job roles for the driverless car, it is the car itself. Okay. So the information, the data collected by the car, they can be, for example, the radar information. And also the camera informations. Okay, and also even for some others, we can also have some other informations. For example, like the pedestrians data sharing or the infrastructure's data sharing, right? So for the time being, maybe it's still only the radar data or the camera data. But in the future, maybe we can have some other technologies to let them as the data inputs for the driverless car. Okay. Okay. Any other question? Another one. One will see the autonomous vehicles being introduced to the public on the streets. This is based on the, I think it's based on the deployment states of the 5G and also the upgrades progress of the streets. Okay? Like I said, the autonomous driving is not only the car itself, but also the environments cooperate with the car, includes the infrastructures, include the roads. So now a lot of car, they are doing the autonomous driving based on the roads. If you write, there is some lines, right? They can analyze the lines and then identify the roads. So for the autonomous driving, in different scenarios, maybe their requirements will be different. For example, in the dense urban, very complicated scenario, there will be a lot of cars, a lot of pedestrians in the roads. But in some special scenarios, for example, in the private campus, for example, maybe in your own campus, your company, you have a small campus. In such, this scenario will be much simpler than the public area. So maybe in the public area, the commercial one, like you said, in the public streets, I'm afraid it is a little bit hard. We have to wait maybe 2 or 3 years. I'm not sure. It is based on your deployment about 5G and also your deployment of the intelligent roads and the intelligent facilities, infrastructures like this. Okay. But the technology now is ready. The technology is ready. Okay, let me find any other questions. Will Huawei introduce a car to the public? Okay, very good question. Like the Apple car. Okay, this is a very interesting question, right? Our boss, Mr. Ren, he said Huawei will never make a car, but he also said before Huawei will never make a smartphone before. So I'm not sure whether Huawei will make the car. But in my opinion, in my own opinion, that Huawei will focus on the systems, the intelligent systems for the driverless car, but not the car itself. You can imagine that the car itself, every car, they also have the control center. So we are focusing on the control center, not the car itself, because this car industry is really, really complicated. A lot of car manufacturers, they have a very long histories, maybe more than 100 years of histories, like the BMW, the Ford, a lot of the Chevrolet, a lot of these car manufacturers, they have a very, very long histories, and they have a lot of experience that the other companies, they don't have. So when you step into these industries, we don't have the advantage compared with them. But we have, compared with these traditional car manufacturers, like Huawei, like Apple, we have some advantages that we are focused on the ICT. We focus on the data analysis, right? The AI functions, right? Some kind of analysis, we have more advantage than them. At least now, currently, maybe we don't have the plannings to make the car, but we can make the controllers of the car. Okay, very interesting question. Next question, how to prevent accidents from cars not recognizing lanes in the streets? What safety features can be applied? Okay, this is also very important things we have to consider, right? So I think, in my opinion, the driverless car, the most important things for driverless car is always the safety, right? Especially for the early stage, when we first launched the driverless car. If some bad news occurs, the people, they are not willing to try this driverless car. So how to guarantee the security? Just now in your question, you mentioned the lanes in the streets, right? And I think this is only one of the mechanism to guarantee the security. We also have a lot of other ways, to guarantee the security. But this one is just like we said, it is based on not only the car itself, but also the roads. So you must change the roads. The road is not like the traditional one. Maybe you need to install some intelligent sensors or some guides maybe to let the car identify them. So when the car, not only the simple lanes, right? Maybe you need to install some sensor to guide the car to drive like that way. Okay. So this is a very complicated jobs to do if you want to guarantee the 100% security. So we need to do more things on the road itself, but not the car, not only the car. Okay, another very interesting questions which I met many times, right? What happens if we lost the 5G signal? This is a very interesting and very important question, right? So first we can imagine like this way. The first one, just in case we lost 5G connections, we have to make some alerts to the car before we lost the signal. So this is the difference from 5G to 4G. So some people, they will ask, 4G, we can also support sharing some information to the car, right? But in 5G, what's the difference between 4G and 5G? The highest throughput, the low latency, we don't talk about this because we all knows that. But in 5G, we also have a very important technology. So 5G, we have these abilities. When the alarm occurs, usually we have the abilities to do some analysis. Before the alarm occurs, we can, the networks, the AI functions, they can send us some alerts. This is based on the big data analysis. So we can do some big data trainings for the alarms or the fault occurs. Before the fault occurs, maybe they have some performance on the data, right? So we can do some analysis. In case of the alarm occurs before that, we can also send us some alerts. Notice us that some accidents may occur maybe in several minutes or in several seconds. So before the 5G base station broke down, we can send some alerts to the car itself. Okay, so this is the first scenario, that's 5G base station broke down. And the second one, maybe we really don't have the 5G coverage. We move to the city, the edge of the city. There is no 5G coverage. In this such kind of scenario, we also have some mechanism. Before we move into the edge of the coverage, we can do some analysis. Maybe we can analyze the signal strength, right? When this signal strength drops lower than one threshold, we can send some to the drivers to let the drivers handle this driving by the drivers. Okay, so this is the second scenario. The third one, to guarantee the 5G security, the reliabilities. This one, we also have some, before we launched the driverless car, we also guarantee that 5G coverage must be very good. So this is the requirements for the driverless car. And the second one, we also have some backup mechanism, some backup one. When the 5G, we lost the connections, we have some backup solutions. So this is also not only the technology solutions from 5G, but also the driverless car itself. When we work together with the car manufacturers, the car manufacturers, they also ask us, like ask Huawei and ask operators. So like the same question, when we lost connections of 5G, how can we handle about the driverless car? Okay, so this one, we need the car work together with the networks. If the networks lost connections, we need to send some alerts to the car itself. And then the car, maybe they just stop. Maybe they will send some command to the people, let the people handle this, right? So this is I think this, maybe in the future, we have more solutions based on this because the car manufacturers and like Huawei, like operators, we all notice this problem. So the first thing we need to guarantee the security, right? Maybe we need to just stop the car. Next question, can you tell us more about the mechanics of autopilots? Okay, the autopilots is for the time being is has already been used in some small in some application scenarios like the private campus or like the airports or the train stations like that. We have already used that, and also some factories. Usually, such kind of pilots, they have some dedicated pass. They only have this pass, single pass, not the other pass. But in the future, we can have this more applications, maybe more complicated pass. And the next question, 5G can be easily disrupted. Can we solve this problem? I don't know what's your meaning about this. 5G can be easily disrupted. I think this is not very hard. So if your networks are very easy to be disrupted, it means that we have some problems on the optimizations or the maintenance. Usually 5G is very reliable. And the next question, can the car be controlled by the person driving it if it was fully automatic? For example, switch between the manual or automatic driving. Okay, this is a very good question. So usually for the driverless car, it's different from the aircraft. Maybe you heard about some news from the flights, right? Like the Boeing flights 737 Max, right? The plane, they control themselves. They don't allow the people control the plane, right? But the car manufacturer, the driverless car itself, the drivers always have the first priorities. So this is the different things between the plane and the car. The driverless car, the drivers always has the first priorities. Okay, so at least for the time being, it is like this. So drivers always have the high priorities. Okay, so this is all the questions. Any other questions? How do you think autonomous driving will affect human life? Wow, this is a very, very big topic. Let me think. First of all, they will change the whole societies, right? A lot of drivers, maybe they will lose their jobs. This is the first thing, right? This is the very serious problem, right? But once some people lost their jobs, maybe there will be some new industries. There will be some new working opportunities, right? But the trend is like that. The new working opportunities will focus on the high tech, very low technology, no efficiency labors. They will have very less opportunities. Okay, so this is the first very important change for our life, the human life. The second one, it is some maybe some philosophy problem, right? So how to deal with the intelligence, the artificial intelligence, the AI. This is the very big topic, right? What's the relationships between the humankind and the artificial intelligence? I think this is the high level of the considerations. So in the future, the driverless car, they will based on AI, the big data trainings, right? I think this is a very, very big topic. I really cannot answer this very good. But in my opinion, there will be some rules, right? One way allow the machines to do something, we must make some regulations for them. They cannot step into the bottom line, right? So this is a very complicated question. But for the driverless car itself, in my opinion, the most serious problem is that they will change the security society level. Some low efficiency labors, they will really be. I don't know how to say it. It's maybe they really lost their jobs. So the societies will be involved to the high tech level. Some kind of people, they will benefit from this technology. Okay. It's a little bit hard to answer. This question is too big. Okay. Very interesting. But we can. This is also one important things we have to face. So we need to consider about more. The technologies can bring us much more convenience, but they also bring us a lot of society problems we have to face. Okay, very good question. Any other question? It's really good for you to have these considerations. So when the new technologies come to us, we have to think about more, not only the technology itself, but also more the deeper things we have to consider about. Okay. Okay, I think we have already answered so many questions. Thanks to TRA have this to give us this opportunity to share our ideas to each other. Okay, and thank you for your cooperations. Okay, so today's webinar we have already finished all of them. Okay, thank you. Looking forward to have the next one. Okay, thank you.